So once again, we want to discuss the simple steps in graphing for the case of reciprocal function, where the simple steps in graphing is the acronym for the step that's going to involve later, which is start with the first step, the type of the function, the shape of the graph, the special point or lines that involve, the intersections points on x and y axis, as well as the last step, we do the graph. So the reciprocal functions that we're going to refer, that basically we can have the form of fx equals to a constant capital A over mx plus c, where the a and m once again not equal to 0, and the a, m, c, k are all happen to be constant. So let's just begin with step number 1. In general, what we happen to find out, the type of the functions here, if it happens to have the functions that can represent in this form here, where I have a over mx plus c, where we can see from the first examples here, 3 over 1 minus 2x plus 4, where the corresponding capital A, m, and c compared with the function highlighted in orange on top. We have a as a as positive 3, m as negative 2, c as 1, k as 4. Similarly, I have minus 3 over x plus 4. I can have a minus 1, m1, c4, k equals to 0, where I don't have any plus constant k there. Then continue, I have fx equals to 2 over 5x minus 1. So these are the corresponding a, m, c, k if you compare on top. Fx equals to 5 over 3x. So again, this is the a, m, c, k that I have corresponding to on top. And basically from all these examples that you happen to see is that the important thing you notice, you will happen to be able to identify the reciprocal functions where we can have our denominators only come with the x term in linear expression mx plus c. Some of the situation you may find out that you have the case like 1 over minus 4x over 2x minus 5, where you have linear over linear in the reciprocal function, and yet this is still in the coverage of our type of function, where by doing long division that you're going to learn in chapter 6 later, we're able to convert this function here into the form of negative 9 over 2x minus 5 minus 2. And once again, it corresponding to the functions that we have in general on top. So go on. So once we identify that what types of function with examples, then we go on with step 2, the shape of the graph. So in here, to determine the shape of the graph for reciprocal functions, the key is referred to the value of a and m, where you find out that this is happen to be the shape that we have by the time I have a divided by m is happen to be greater than 0, which is positive. So for example, like this case here, in here your a is 1, your m is 1, so a over m is positive, a is 2, m is 3, a is 2, m is 3. So all this division will give you positive a divided by m. Similarly, you can have the constant and also the x terms coefficient, both of them is negative. For example, a minus 1, m equals to negative 1. So when time we do the divisions, you find out that you have a over m greater than 0. So this is happen to be the shape of our graph, where we have two dotted line there in red and in blue as the asymptote that we need to take notes. Then another possible shape that we can have is that if you're just corresponding to the previous one, you just have the other two positions here come with graph, and then the original position with graph we just happen to be make it empty. You can consider from here to the other one is either you consider we flick horizontally or we flick vertically. Either one will do, it will reach to this result here. Or just simply we consider as if like first, second, third, and fourth quadrant. So for the case A divided by m greater than 0, I'm taking the first and third quadrant. The other one, I'm taking 2 and 4th quadrant. And the corresponding examples for the case A divided by m less than 0, it will happens to be this result here that I have shown you. Where, for examples, you can see that this is A equals to -1, m equals to +1. So when the time I do the division, I get less than 0. Similarly, go for the rest. So this is the two shape of graph that you need to take notes for reciprocal function in our discussion here. Then continue. What is happened to be the special line that we want to discuss here is that the special line is referring to the vertical and horizontal asymptote. Where how we obtain the vertical and horizontal asymptote? Vertical asymptote will refer to mx plus c equals to 0. Horizontal asymptote, we just refer y equals to k. So from here, from the example that we list out just now, in step 1, I can identify what is happened to be the vertical asymptote and horizontal asymptote accordingly. For example here, to get the vertical asymptote, I take 1 minus 2x equal to 0. It gives me x equals to 1 over 2. The constant 4 here contribute to the horizontal asymptote y equals to 4. And if you refer to the last examples, I can happens to obtain the vertical asymptote easily. 2x minus 5 equals to 0, even though without doing the conversions here in red, I can get the answer. And for horizontal asymptote, actually there is a trick there. We can happen to find out the horizontal asymptote, where the horizontal asymptote here, if you happen to notice, you just consider the coefficient of the x on top and the coefficient of the x below. You divide them. So -4 divided by 2, so I get -2. Of course, if you can do long division and get this result, it's pretty obvious to find out the horizontal asymptote. So once again, this special line here, it happens to help us to do two things. First, it helps us to decide the y and x intercept, whether they exist or not. And also, they help us to determine what is the domain and range. By right reach until this part here, I can decide the domain and range. Go on, step 4. By using the info until step 3, by doing a rough sketch, I can identify whether do I have any x or y intercept, and then if they exist, I calculate accordingly. Where y intercept, I substitute x equal to 0 to find out what is the y intercept. For x intercept, I will have my fx equal to 0, or I should say I have my y equals to 0. And usually I will suggest to solve using calculator, which is faster. Of course, you can use manual way that you substitute kira by yourself to get answer. Then at last, make use of the information from step 1 until step 4. We go for our graph sketching, and make sure you do label the xy axis, origin, the graph. In this case, it is not referred to the vertex. It will refer to the case of our important line here, the special line here, which is happen to be the asymptotes. The asymptotes, the horizontal and vertical asymptotes. Then followed by the xy intercept. Therefore, this is what we happens to have in general on the graph sketching for the reciprocal functions.